Olá, teachers do Brasil, sejam bem-vindos novamente a mais uma sessão da ELT Week 2024. É uma honra para mim estar aqui com vocês hoje. Meu nome é Emília Burarak, eu sou gerente de projetos da área de língua inglesa aqui no British Council, no Brasil. Eu vou iniciar com a minha audiodescrição. Eu sou um homem branco, hoje eu uso barba, tenho cabelos e olhos castanhos, e hoje eu estou usando uma camisa de listras brancas e roxas. Continuando com a nossa programação para hoje, na ELT Week 2024, eu queria compartilhar com vocês que esse é o nosso terceiro ano que temos educação e também é o primeiro ano que temos o apoio do Centro Paula Souza, que é a maior rede de ensino técnico da América Latina, não só do Brasil, mas da América Latina também. Então a gente está muito feliz de contar com o apoio dessas duas gigantes instituições. Hoje a gente vai conversar com o professor, com o doutor Mariano Felice. A palestra dele se intitula AI for Language Assessment. O trabalho do professor Mariano envolve a análise de como a inteligência artificial e o processamento de linguagem natural podem ser usados para aprimorar tanto o aprendizado como testes assistidos por computador, a partir de uma curadoria de conjuntos de dados e apoia colegas na adoção de novas tecnologias. Esses colegas seriam os professores na sala de aula. O doutor Mariano Felice também é pesquisador visitante na Universidade de Cambridge, onde foi pesquisador associado como parte do Instituto Alta, antes de se juntar ao grupo ARG do British Council. Ele tem um doutorado em ciência da computação pela Universidade de Cambridge também, e trabalhou extensivamente no processamento natural de linguagens para aprendizado e avaliação de idiomas, incluindo correção de erros gramaticais, digitação automática de erros, avaliação de sistemas, geração automatizada de testes, close, e calibração de itens. Mariano Felice também publicou muitos artigos científicos em conferências de PNL, ou processamento natural de linguagens, e de primeira linha. Ele deu palestras e tutoriais em diferentes locais do mundo e é revisor regular de workshops, periódicos, revistas e conferências na área dele. E, sem mais, eu vou deixar vocês com o Dr. Mariano Felice.
Hello, and welcome to this session on AI for language assessment. My name is Mariano Felice, and I am a senior researcher and data scientist in the Assessment Research Group at the British Council. And today I'm going to talk about how AI can be used for language assessment, what it can and it can't do, and how it works behind the scenes, so that we can get a clearer idea of its capabilities and limitations. So I'd like to start by talking a bit about AI in general, especially because nowadays AI seems to be synonymous with ChatGPT. And although ChatGPT is AI, AI is not only ChatGPT. AI is a lot more things. There are lots of other techniques, tools, and applications. So let's think, for example, of face detection on your phone, or optical character recognition when you scan a document, or when you talk to Siri on your phone, or the film recommendations that you get on Netflix. All these things are AI. All these things are made up by different techniques and tools and applications that come from AI. And just like we can use them for those things, we can also use them for language assessment. So there's a whole range of things that we can use behind ChatGPT, and hopefully we'll see many of them during this talk. So there are many benefits of AI for language assessment. So I'd like to go through some of them. So the first one that comes to mind is speed. So as you can imagine, it's much faster for a machine to process and grade a piece of text, for example, than it is for a human examiner. And also machines could grade texts or essays from many students simultaneously, which allows us to, for example, address a whole cohort of students simultaneously. So that's a great advantage of using a machine. Also, if we think in terms of accuracy, it is fair to say that provided a machine learning model is properly trained, it can achieve human accuracy or even surpass human performance on certain tasks. And that's something that we see, for example, for something like parts of speech tagging, where parts of speech taggers have higher accuracy, for example, than humans. So as we see, we can rely on AI models for accuracy as well. There's also a question of availability. So provided we have electricity, machines are available 24/7, so we can use them on demand. They are always there for us. They don't get tired, they don't need to take a break, they don't get sick. They're always there, they always work. And this is something that is very useful because especially in cases or scenarios where we can't afford to have humans support a particular activity, we can use machines. So this is a great benefit to have, a piece of machinery that is always available, providing a service. Also, there's a question about fairness. This is something that people talk a lot about nowadays because of ethical issues that have arisen with the popularity of AI. And since a machine is basically impersonal, it doesn't have any of the unconscious biases that a human examiner could have. So we could think that maybe machines can practically remove any biases that a human examiner could bring with them. However, the fairness of a machine learning system is going to be highly dependent on the training data that was used. So if the training data has any biases in it, then it's fair to assume that the model will replicate these biases. So for that reason, if we want to maximize the fairness of an AI system, then we have to make sure that we minimize all the biases in the training data. Now, if that's not possible, because it's hard, for example, to detect the bias in the data, and we observe biases when we actually use the system, we can still do some things to mitigate these undesirable consequences. So, for example, if we think of a case where students from a particular community of L1 speakers seem to consistently have higher scores because there's an inherent bias in the training data where everybody that has a particular L1 automatically gets a higher score, then we can take some steps to reduce the effects that L1 information could have within the system and minimize that importance within the system so that it will not affect the results in a way that would be unfair to speakers of other L1s. And finally, I would like to mention the issue of consistency. So a machine can repeatedly and consistently generate the same output for the same input, which is something that we can't always guarantee with a human examiner. Even though we know that human examiners go through extensive training and supervision by senior examiners, we can't really rule out that different examiners, for example, could give different scores to the same piece of writing or to the same student, or even that a single examiner could rate a piece of writing differently at different points in their life. So for all these reasons, we can consider that AI could be beneficial to language assessment. So now let's look at how we could integrate AI in language assessment. So in what way can we use AI for language assessment? And the most common way in which we do this is by developing auto-scoring or auto-marking solutions. So these are models where we receive an essay or some speech production as input, and the model will produce a score that will be a reflection of the quality of that essay or spoken production. Now, these auto-scoring or auto-grading solutions, they provide a grade which can be of different types. So they can be a numerical score, for example, or they can be a category such as a CFR level, or even a proficiency level, let's say beginner, intermediate, and advanced, or it could also be a binary outcome, something like a pass or fail. Now, these scoring systems typically score their input on multiple dimensions. So these are dimensions that we think of in advance. And we can have a system for each of the dimensions and then have another system that gives an overall score based on the output of all these other subsystems, or we can have just one single system that scores on multiple dimensions, including an overall score. So let's think of what dimensions we could use for different types of input that we could expect. So, for example, if we think about written production, we can think of aspects or dimensions such as vocabulary, punctuation, grammar, organization, task completion, register, etc. Whereas if we think of speech production, for example, we could think of more specific aspects such as pronunciation, prosody, fluency, as well as many of the aspects that we also use for written production, such as grammar, vocabulary, task completion, and so on. Now, how are these models built? So we know what we expect of them. We know how we can benefit from them, but how do we build them? So the way that these models are built nowadays is by the use of machine learning. So machine learning is a discipline within AI that is concerned with the techniques that can be used to make a machine learn to solve a task from examples. And there are different types of machine learning. In this particular talk, I will only focus on what is called supervised machine learning, which is a kind of learning that occurs when we have examples and their labels. So we have examples and the way that they have been solved. We have examples and the expected output for each of these examples. So we're going to see now how this works through the whole machine learning pipeline. So here I'm showing the different steps that are typically involved in a machine learning process, and I'd like us to go through each of them in detail using automated essay scoring as an example. So the first of these steps is data collection. So this is the stage where we collect all the data that we're going to use to train and test our systems. Something that we have to take into account when we collect our data is that it has to be representative. It has to be representative of the target population that we're going to use our system with. So it has to have the same characteristics. It has to have from the same population. It has to come from the same population. So apart from that, we also need to think in terms of how much data we're going to need. And in this regard, we always say that we need as much data as possible. And this is because the more data that we use, the higher the performance is going to be, the more accurate these systems are going to be. So for that reason, we always try to collect as much data as possible. This means that typically we would think of hundreds of examples or thousands or even millions in the case of some complex problems. Now, once we have all these examples in our collection, we split it into 3 different sets. So the first of these sets is what we call a training set, and is the collection of essays, in this case, of examples that we're going to use to train our algorithm, to train our model, to train our machine. This training set is the biggest set of all these 3 sets and contains roughly between 70 and 80% of our data. Then we have a second set, which we call the development set, that we're going to use to optimize the models that we build. And finally, we have another set that is called the test set, and this is the the collection that we're going to use to compute the final performance of our models. Now, we have to solve a little problem before we start training our models. So the problem that we have is that machines don't understand images or video or audio or text. They only understand numbers. So for that reason, we must represent every example that we have in our collection as a set of numerical values. So we have to find a numerical representation that the machine can use as the input to the algorithm and as the basis for the decisions that it's going to make about how that input is linked to the output. And there are basically two ways in which we can perform this conversion of non-numerical data into a numerical representation. The first of these methods is what we call a feature-based approach. So this is an approach where we define what is important in the input in terms of values, numerical values, indicators, characteristics that we find in the input that could be quantifiable. This is essentially a manual process because it's us who have to come up with a list of features and who have to implement how these features are going to be extracted and computed. On the other hand, there is also an automatic method of finding numerical representations for the input that comes from the field of deep learning. So these are more modern techniques that can automatically detect the aspects of the input that could be important and informative in order to help machine learning algorithm build associations between the input and the output. The problem with these deep learning approaches, however, is that they are very abstract and not really transparent to the user. So in many cases, we don't really know what the machine is doing. We can't really tell what kind of information it is extracting. It's not really transparent to us. It's not like the features that we define that are very clear cut. These are more abstract representations that generally have no obvious meaning to us humans. Okay, so once we have defined our set of features, let's assume that we're working with a feature-based model. We've defined the features. We now need to extract this for each of our examples. So let's think, for example, of what features we could extract in the case of essay scoring. What features would we extract to represent an essay? What characteristics of an essay would be useful for a machine learning model to draw conclusions on? I've included some of them here. So as we can see, there are all sorts of different features. They've been grouped into different categories, into different dimensions. So we can see, for example, that if we want to analyze things with regard to content, we have things like what overlap with a written prompt, with a written question. That's to check, for example, if we're using the same kinds of words that we have in the original question. Also, if we want features that look into language use, we have things such as the frequency of the vocabulary, or type token ratio, or error rates for grammatical errors. And then if we want to look more into structure, we have things like essay length, so the number of words that we have in the whole essay, also the number of words per sentence, or average sentence length, and so on. Now, it is not a strict requirement that all the features that we define have to be numerical features. As we can see here, some of the features are more abstract, such as cohesion and coherence. But at the end of the day, we will have to convert all the features that we define into a numerical value. So even in the case of more abstract features like these ones, we could still think of building, for example, an auxiliary model that would be trained in a similar way that we are training this model for essay scoring. But in that case, it would be a model that would generate, for example, a coherence index or a cohesion index. So by using an auxiliary model, we can turn these features, these abstract features, into some sort of numerical value. Also, it could be the case that we define features that have categorical values. So let's think, for example, of a feature for the most frequent word in the essay, for example. So the value of that feature is going to be a word. So in those cases, we also have to think of a conversion of those words into a numerical value. Now, thankfully, machine learning provides us with certain transformations, so there are well-known methods that we can use to transform these categorical values into numerical values that we can easily use for our training later. So we now have a set of features. So what we have to do next is write pieces of code that would carry out the extraction of these features from each of these examples and generate these numerical representations, these feature vectors, as we call them. So by doing this, we will now have a mechanism of converting every single example in our training data into a feature vector, into a numerical representation that we can use for training in our machine learning algorithm. And that is precisely what we're going to do next. So the next step is the actual training. So in this step, we're going to take all our training data, or rather all the numerical representations of all the examples in our training data, together with their labels. So in the case of essay scoring, we're talking about the representation of every essay alongside the scores that we have for each of these essays. So that is the data that we're going to feed into a machine learning algorithm. And this algorithm is just some computer program that is able to find associations between those feature vectors, those numbers that we have as features, and the output, which are scores in this particular case. And the result of this algorithm trying to find those associations is what we call a model. So this model is going to have the knowledge, the know-how of how new scores, in this case, could be derived from new essays. So how new input could be derived, predicted from new unseen input. So the next step is what we call fine-tuning. And this step is necessary because every time that we build a new model, that first initial model isn't necessarily an optimal model. That's generally not the best model that we can obtain from training. So what we're going to do at this stage is use our development set to test our model and start tweaking the machine learning algorithm, start changing some things in the algorithm to produce newer models that will hopefully be better than the one that we have. So we first start by training a new model like we did earlier. And using this initial model, we're going to take all the essays in our development set, we're going to feed them into the model, and we're going to obtain the predicted scores. Now, because we have the true scores in our development set, we're going to compare these predictions with the true scores, and we're going to compute some metric of performance, some metric that tells us how close or far away are the predictions to the true scores. Let's assume we compute accuracy, for example. So we will keep a log of the parameters or hyperparameters that we've used in our machine learning algorithm during training and the resulting accuracy of using those parameters. And next, we're going to make some changes to those parameters in the algorithm and train again, obtain a model, and repeat this testing process using the development set. And so we repeat this cycle many times. So we train, we test, and we tweak. We repeat this process until we see that we can't get any further improvements on our model. So that's when we stop. And that model is the final model, the optimized model that we're going to use. So the next stage is the testing stage. And this is what we're going to use the examples that we reserved in our test set to compute the final performance of our model. Because we now have the most optimized model from our training, we can use all the essays that we have in our test set, feed it into this model, get the predicted scores, and just like we did with the development set, we're going to do the same with the test set. We're going to take the true scores that we have, we're going to compare the predictions to the true scores, and compute this final performance. And this final performance is the one that we are going to report when we talk about our model. And this is what is going to tell us how accurate our system is, how precise it is. So, for example, let's assume that we get a final accuracy of 90%. What this means is that out of 10 examples that we see as 10 unseen new essays, 9 of them are likely to be accurately scored, while 1 of them is going to be inaccurate, on average at least. So by having this information now, we know what to expect when we use this model in the real world. So we shouldn't be surprised if every now and then we see an inaccurate score, for example. And that's the reason why every time that we use one of these models, it has to be under the supervision of a human that's responsible for monitoring how the system behaves. We will never use these scores from AI systems blindly. There's always going to be a human in the loop, as we call them. So there's always someone that has to be, someone responsible for how these systems are used, how we are using the output of these systems. So we've seen how these feature-based models work. We define features. Those features are used to characterize the input, the essays in this case, and those feature vectors are then used during the training process to build a model that can predict new scores for unseen cases. Now, they are very simple, but they are also very effective, and they have many advantages as well as disadvantages. So let's have a look at some of them. So one of the advantages of these models is that we are the ones that define what is important. So by defining the features ourselves, we are the ones that are telling the algorithm what to look for, what is important in the input, what characteristics are informative in order to make a decision about what score to give to an essay, for example. Also, these models are in general very easily explainable. That's because the algorithms are fairly simple. Also, as I said, we define the features, so it's very simple for us to figure out the correlation between the values of the features and the values of the output, the score, for example, of an essay. So it would be very easy for us to investigate why a particular score corresponds to a particular essay. In general, when we use these kind of models, we also get information about what features are the most important, or how the features are weighted within the model in order to produce a score. So for that reason, it's very easy for us to explain how a score is derived. And finally, they are fairly easy to implement, especially compared to more complex algorithms, because, as I said, they are algorithms that are fairly straightforward and easy to follow, so they are not particularly challenging. Now, among the disadvantages, sometimes we need to resort to expert knowledge, so basically domain experts. So especially if we are modeling a problem that we are not particularly familiar with, because we have to define the features, we have to define what's important, we have to characterize the input. We might not know what is important in a particular problem. However, when AI practitioners start working on a particular problem over time, they start to develop an intuition of what are reasonable features for different kinds of problems. But as I said, in some cases, we do need to resort to domain experts. Also, the fact that we have to define all the features manually and we have to write all the code for the features and structures can make the whole process a bit tedious. Also, because the accuracy, the performance of the models is directly dictated by the features that we use, that means that we are somehow limited by our own creativity. So if we don't come up with a creative and useful set of features, then it's very unlikely that we will get a very accurate model, a very successful model. So in a way, we are limited by our own creativity when we define the features. And finally, what happens with these models is that they are not as powerful as newer models, more precisely models that belong to deep learning, as we will see later. Still, these models are very good, for example, for regression problems, so problems where we are trying to predict a numerical value, such as score in this case. So for these kind of problems, they work very well. Now, moving on, we can also use a different type of model to solve a problem. And as I mentioned, there's this new set of techniques called deep learning models. They became very popular in 2010 and became more and more popular with time. This is actually the kind of technique that underpins things like large language models like ChatGPT and so on, and also most of the modern algorithms for solving very complex tasks. So what are these deep learning models in particular? Well, these models are basically big and complex neural networks that try to mimic the way that the human brain works. A neural network is a particular type of AI model that is composed of a series of layers, each of which has multiple neurons. So these are units that carry out calculations, and by having a stack of many of these layers, these models can abstract a lot more when they try to solve a task and have much more intricate representations for the input. And that gives them the power to be much more accurate and solve much more complex tasks. Now, a good thing about these deep learning architectures is that, unlike feature-based models, they don't require explicit feature extraction. So what happens instead is that they figure out by themselves what is important in the input. There's no need for us to specify what they should be paying attention to. In this figure, I attempted to show what a deep learning architecture looks like for the case of essay scoring as well. So the first thing that we notice is that an essay is converted into a numerical representation, just like we did with our own features and our feature vectors. So in the case of deep learning models, we have a similar representation that is called embedding. So these embeddings are also a kind of feature vectors that convey information about each of the words in our input, each of the words in our essay. Now, after this initial conversion of the words into embeddings, these embeddings are fed into the rest of the network. So they propagate through the whole network, through all the neurons, so that the neurons can adapt their state and find, again, the necessary associations between these embeddings and the score that they are supposed to predict. Now, something particularly surprising about these models is that, as I said, we don't explicitly define what is important, what dimensions it should be looking at. Instead, these models figure that out by themselves. And as we can see here, what has been found specifically by researchers working on this topic is that, in particular, the first layers of a neural network tend to learn the more basic aspects of the input. So in the case of an essay, for example, we're talking about things such as basic linguistic features, maybe vocabulary or punctuation or syntax, whereas the last layers of the model tend to learn more abstract things and more conceptual things, such as maybe things related to coherence or organization or discourse, more high-level aspects of the text. And this is something really amazing, because this is not something these models have been explicitly trained to do. It just happens that they learn these aspects, these characteristics of the input, which at the same time makes them very, very powerful. Now, just like any other model, we have advantages and disadvantages to these kind of models. So one of the advantages is that they are very powerful. As I mentioned, we are able to solve many complex tasks and also achieve much better performance than using more basic models. There's also the advantage that we don't have to define features ourselves. They figure out what's important by themselves. They can also learn more abstract concepts than other models. As we saw, the deeper we go into the layers, the more abstract concepts it learns. And one particular advantage of these models is that they are highly reusable. This means that once we build and trained a deep learning model for a particular task, we can generally use that model that we built as the starting point for another model that solves a similar problem. So let's think, for example, that we build a model to correct grammatical errors in text. Then it's very likely that we can use that model as a starting point for a model, for example, that gives scores to essays, that does auto scoring for essays, because basically the kind of information that they deal with is roughly the same. So it's an essay and there is this embedded information about correct language. Now, among the disadvantages, we can see that these are much more complex algorithms. For that reason, they are also highly unexplainable. So it's very hard to follow some of these algorithms, and it's very hard to understand why they produce the output that they produce. Even if it makes sense to us, it's not straightforward to find the path that leads from a particular output to the characteristics in the input. It's not really that straightforward to make that connection. Also, given the complexity, they are computationally very expensive. So in general, we need things like special graphic cards or special equipment to make this training faster. Otherwise, it would take days or weeks. And also, they tend to require massive amounts of data in order to provide decent performance. This is because they have such a complex representation that they necessarily require lots of examples, so that all these levels of abstraction within the network work very well. Otherwise, these models can't really generalize from just a few examples. Now, the last kind of models that I would like to talk about are large language models, things like ChatGPT. So these are deep learning models, just like I mentioned earlier, that have been trained to understand and produce human language. They have been trained on a lot of examples of written language. And we know that large language models like ChatGPT have made AI available to everybody, basically. So now everybody has the ability to use AI in their everyday activities. Now, if we think in terms of how we could use a tool like ChatGPT for language assessment, we can think that maybe we can write prompts that could help us do some tasks within language assessment. So if we think, for example, of scoring an essay, just like we did before with other models, we can write a prompt, possibly, where we specify a rubric. So we can say, for example, the kind of criteria that we want to score an essay on, and also the scale that we will define for each of these criteria. And then basically submit an essay and give ChatGPT the instruction that we want it to be rated based on the rubric that we provided. And then we will obtain something like what we see on the right-hand side. So for each of the criteria that we defined, we're going to have a little description, justification, alongside a score for that dimension, and most of the times also an overall score that is based on the scores that have been given for the different dimensions. Of course, the output will depend on the prompt that we give it. We give the language model. So it's all about our creativity and how precise we want to be when we define how things should be scored. So as an advantage, we can mention that these models are very powerful. They are very easy to use. We just need to write in human language. There's there are no technical skills required, basically. They're also very versatile. They can solve lots of different tasks. We are now concerned about language assessment, but we can use it to produce any kind of text and even solve some problems. Now, some of the disadvantages of these models for language assessments in particular is that they can be inconsistent. So this means that even if we're using the same prompt on the same essay, if we try it on different days, for example, it might give us different scores. So for this reason, we can't really rely on them so blindly. Also, the kind of output that we get, or even the scores that we get, will depend on the user prompt. So maybe for the same essay, different prompts will give different output. And finally, they are somewhat unexplainable in the sense that just like any other deep learning model, we can't really know how the scores were derived, although in this particular case, if we are providing a rubric, then that can give us some sort of explanation about how a score was derived. But the truth is that we don't really know what kind of calculations are going on under the hood that would produce one particular score from the input that we provided. So we've seen all these different ways in which we can create auto scores, in which we can assess a piece of writing, for example, but there is a lot more AI that we can use in assessment. There are lots of other techniques and tools that are not necessarily for auto scoring, but for other aspects of language assessment that could also be very useful. And I would like to mention some of them. So some of them, for example, are taggers and parsers. These are very common tools that we use when we process text. So taggers, for example, would give us the ability to tag all the words in a piece of text with particular information, for example, parts of speech, whereas parsers would give us information about phrase structure, dependencies, and so on. Language models are also a very common tool in language processing, and these are components that know how to assign probabilities to a sequence of words and can also generate a sequence of words based on probabilities. And these are very valuable because they can help us assess the correctness, for example, of a sentence, or which sentences are more likely than others, something that could be particularly useful, for example, for speech recognition systems. Whereas they can also generate text much in the style of generative AI. Then another common task within language processing is grammatical error correction. These are systems that detect and sometimes also correct grammatical errors in a piece of text. And these components are very important because in general they are used in either auto-scoring solutions as part of a feature, or also as indicators within digital tests, computer-mediated tests. So they provide very valuable information about students' proficiency. Also, we can make use of generative AI, just as I show with ChatGPT. So in particular, when it comes to item writers, something like generative AI could help them write content for tests, or write reading passages or questions. So it can also be a very useful tool within the realm of language assessment. Also, automatic speech recognition is a key component in computer-mediated tests that have a speaking component, because this is the tool that will provide transcriptions of the speech that we get from the candidate in a computer-mediated test. So this is the entry point for capturing the words that somebody says, and from which we can then do further assessment, just like we do for written production. Also, using common AI techniques, we can gain some learner insights and, for example, see how they interact with the system, or estimate their proficiency, or estimate how well they are doing in a test, for example, based on the number of questions that they get right or not, and use all of this information, for example, for test adaptation. And finally, we can also use AI for something like remote invigilation, where a machine could supervise the behavior of a student during a test using a webcam, for example, and flag up any suspicious behavior. Now, we can see how all these components could work together in a single ecosystem, where some of these components would be directly facing the user, and others will be used internally in a solution, for example, for computer-mediated test, for example. So this is just an example of how all these components could work together, how we could use different things from AI to achieve a common goal. Now, there's a lot in AI, as I showed you just now. However, there are very few international examinations that make use of this technology. The only thing that these tests have in common, for example, is that they use auto-scoring for speaking and writing. But other than that, then only a couple of them use AI for other purposes, such as generating content or adapted tests. In particular, it is Duolingo, the one that makes the most use of AI, and I think that's fairly understandable because their offering is really heavily focused on technology. Now, I would like to highlight a few points to wrap up, so that we take these things into account when we think about using AI for language assessment. So the first thing that we have to remember is that all these systems are not perfect. They all have a degree of error. So for that reason, we can't trust them blindly, and we have to make sure that there's always a human in the loop that will step in if we see that something doesn't go right, that there is an error, for example, in the output that we get from these systems. Also, for high-stakes decisions, we can't rely on a system entirely. So high-stakes decisions should not be fully automated. Any kind of decision shouldn't be fully automated, but in particular, high-stakes decisions could have a very serious impact on somebody's life. So it is recommended that we don't rely on these systems entirely. It's okay, however, for example, if we want to use some of these systems for practice tests, for example, that would be a low-stakes scenario. So in that case, we don't really face the same kind of issues so we would face if we were talking about very serious decisions. And finally, something we have to take into account is the potential ethical issues that the use of AI could have on people's lives, and in particular students and candidates. So we have to take into account questions regarding bias, as I mentioned earlier, but also integrity, privacy, dignity, security. All these things are questions that are arising now from the widespread use of AI, and definitely things that we have to take into account. And we have to make sure that we take ethics by design if we can. So we have to think of ethics from the very moment that we conceive an AI solution, and not once the systems have been implemented, because then it might be a bit too late to be able to fix some of these problems. So this is all from me. I hope you enjoy this talk, and this has given you a general overview of what you can expect from AI for something like language assessment. And thank you for tuning in.
Mongevir, ele diz, quando eu conseguir me especializar nesse conteúdo de inteligência artificial, eu terei uma ferramenta muito poderosa nas minhas mãos. Acho que isso é uma mensagem muito importante que o professor Felice nos passou, que a inteligência artificial é uma ferramenta dentro da sala de aula, e não um inimigo, não um potencial inimigo. Então, muito bom, Mongevir, ele está ciente que, de fato, é uma ferramenta para nós, professores, dentro da sala de aula. Elizabeth Carolina Tenório, ela diz, quando os meus alunos me enviam um vídeo do YouTube, eu reviso as legendas que são geradas por AI, porque eles mostram se a pronunciação, se a pronúncia é correta ou dá para compreender. Sim, muito bom. Essa ferramenta da legenda automática que é gerada por inteligência artificial é uma ferramenta muito, muito, muito legal, muito útil, que ajuda bastante não só na leitura, certo? Mas também na pronúncia, como a professora Elizabeth disse. Então, a Maria Vicente também, ela diz que ela está começando a trabalhar com AI também dentro da sala de aula dela. É muito bom. Oh, we have Professor Mariano online as well. I don't know if you can hear us, Professor, or if you can see us. I don't think we can hear you, Professor Felice. Oh, I'm so sorry. We can't hear you. Can anybody else hear Professor Felice? We can see you, Professor, but we cannot hear you. Sure. Thank you, Professor. Dr. Felice is trying to fix his microphone. Have a few interactions, yes, on the chat.
Hello.
We can hear you now, Dr. Felice.
Brilliant. Hi,
Awesome.
everyone.
Hi, thanks for joining us. We have a few interactions and questions on the chat. So his name is Mongevid. Yes, he's asking, how can we see and visualize AI as a powerful tool and not as an enemy or a potential enemy for English language teachers?
Well, I think we have to understand that this is a tool that is supposed to complement what we're doing, not to replace human assessment. So I think I tried to show it in my talk, the different ways in which we can use these tools to help us develop a test or do automated assessment. But by no means is this a replacement for what we do as humans. So I think it's all about, first of all, our attitude, having a positive attitude, then how we use these tools. Of course, we don't want to use these things, for example, for something that requires high stakes decisions, for example. So it also depends on us on where we decide to employ these tools. So by being in control, we can make sure that this works in our favor and not against us. So yeah, it's not, we don't have to see this as an enemy. This is not here to replace us, but to help us.
Amazing. A powerful tool, like he said. Very good. Elizabeth Tenorio, she's asking, would you recommend YouTube's generated, sorry, it's in Portuguese, generated subtitles as a tool for English language classes?
Yeah, I think that can be very, very useful for listening exercises, especially, and it can be very accurate as well. So yeah, that's a very, very simple tool that can be very effective.
Amazing. Perfect. Another question from Elizabeth. She says, I really like this idea of centering yourself in the individual as a teacher, understanding AI's job as a tool and not as something that will replace us as teachers. She's saying, what do you have to say about that, Professor?
Yeah, well, as I mentioned, I mean, this should be an aid and not a replacement. And there are lots of things that we are perfectly aware that AI can't do, and this is where humans are very valuable. So an AI tool, for example, can't understand the social, economic context, for example, where learning takes place. It can't be empathetic. It can't empathize with a learner. It can't understand somebody's frustrations or struggles. So this is where our human factor comes in, and that's why we are still essential.
Right. It's something that probably it's not going to be maybe taken into consideration by AI in many, many, many years, right? Like you said, social interactions, economical features, geographical stakes as well.
Cultural awareness. And I would say, even if we start to see that some tools try to move towards the detection of emotions and trying to understand somebody's feelings, these things are still artificial, and obviously they can't replace human interaction. And I can't see why anyone would actually prefer to have this sort of emotional connection with an algorithm instead of a human. So even as we see these things are starting to happen, I don't think this will replace the human factor at all. In fact, we see also that many of these applications that involve emotions, for example, the detection of emotions, they are not they are, I wouldn't like to use the word forbidden, but to some extent they are. So we see, for example, in the European Union AI Act, some of these uses of emotional detection are not permitted. So, and in particular, education is one of them. So we're not supposed to be using, the detection of emotions in assessment, for example, because that's something that is concerned with human interactions and ethics and moral issues that, as we know, are best left to humans than machines.
Absolutely, 100%. I think you mentioned something really important. In order for any student to learn, they must be able to emotionally connect to their teachers, right?
Absolutely.
Amazing. Well, Dr. Felice, thank you so much for your time. We're in very different time zones, so we appreciate that you took the time to join us for this very quick Q&A session. And I just want to remind everybody that we'll be back for some more sessions for the ELT Week Brazil 2024 at 5 p.m. Brazilian time. So once again, Dr. Felice, thanks for joining us.
Thank you for having me. Bye-bye.